Hello friends, welcome to the second part of this session, and the next chapter, next part which involves is pulley string block system. So gradually we will be finding out the implementation of this constraint. Look out here. Again, this is three parts. So this is the combined part, the pulley attached with the string, and the string will be carrying different blocks. So one assumption again here we need to take is that the mass of pulley is 0. The similar manner which we studied in the previous session, that the mass of string is 0, the similar pattern we will be pre-assuming here that the mass of pulley is 0. But this pulley pre-assumption is only valid in laws of motion. If we will be studying the rigid dynamics, rigid mechanics, there the mass of the pulley will have some value, and accordingly the process is moved on. So now suppose this is a fixed pulley, and this pulley has been connected with the two blocks with respect to a string. This one is M1, this one is M2. Again, the same concept which we studied, as you remember, that the velocity components or acceleration components of all the blocks along the direction of the string remains constant. So suppose if this block is moving with velocity v2, it means this point, all the points will be moving in downward direction with v2 velocity. So this point will be moving in upward direction with the same velocity v2. Why? Because the velocity components of all the points along the direction of the string remains same. So the magnitude of the velocity will be same. The magnitude of the velocity of the two blocks will remain same, that will be equal to v2, but direction will change. Since this is moving in down direction, so as it is obvious that this block will be moving in upward direction. Now suppose, for example, I am taking one example, that this block is connected with this 2 kg system, and this is 4 kg system, and if I am saying this velocity, this is moving with 3 meter per second, it means all the points on the string will be moving with 3 meter per second in downward direction in this side, and the same pattern all the points on string in this direction will be moving in upward direction with the same velocity. This is what the constraint pulley relation. Now one thing is to be remembered, that this relation has some specific importance, in the sense that every time you need to care about few points that I will be discussing in respective manner. Now I will be generalizing some facts, some generalization. Suppose this is the condition where we are assuming that the pulley is fixed. But every time pulley won't be fixed. There is a situation where pulley also can move. So in this direction, in this point of time, we need to remember the two facts. The one रुक जा रहे हैं, कोई दिक्कत नहीं ना है. The one, that the pulley is fixed, and if pulley is fixed, it means all the velocity components of the different blocks attached to the string will have the same value. Direction may change. बहुत ऐसा सटा दिया थोड़ा. So the generalization is that pulley is also moving. Suppose there is one block attached to this system M1 and this is M2. As I have assumed that I will be generalizing the fact that this pulley is also moving. So suppose the velocity of the pulley is V and the velocity of mass m1 is v1 and this is v2. Suppose we are taking one example and we will be generalizing the fact in last stage. One conclusion is coming out. So this is the overall condition. The condition is again the two block system attached to the pulley. Pulley is massless and in parallel this pulley is also moving. The concept here is very simple again to remember, that suppose I am again redrawing the fact. So this pulley is moving with velocity Vp. Suppose this is moving with V1 and this one as V2. One point that has to be remembered, that in this session which I have discussed, that if pulley is fixed, the two blocks attached to the string will have the same velocity. But this condition is not valid when this pulley is also moving. This pulley is also moving means, suppose this pulley is moving with velocity Vp, so this velocity will have the impact on this V1, and similarly this velocity of pulley will have the impact on V2. So two different conditions starts coming here. So the important point here is that the velocity components of all the blocks remains same only when the pulley is fixed. Now we are going to generalize some formula, some standard formula, and this formula will help you out to solve the various examples, the various questions related to the constraint. Suppose this is what the generalized question is, that this is a pulley and pulley is massless, moving with velocity Vp, this one is V1 and this one is V2. We need to generalize the concept. So what can we do? What are the options remaining with us? The one is that since this all relation is with the constraint fact, so we can implement the properties of this string. As we know that the length of the string is constant. Length of the string is constant. This length plus this length plus this length remains constant. This we assume that the length of this section is x1, the length of this section is x2, and suppose this is the amount of length that is existing on this pulley, and that will be of the amount of some pi r, and that will be constant. So one condition here is that this length will be moving, it will have some fluctuation. Why? Because if this is moving in upward direction, the length will be shorter, coming down the length will be higher. Again the similar pattern will be this also, but this pulley length will always remain constant. So now we can assume that, we can say that the whole length of the string is constant. It means this length x1 plus length x2 plus the amount of length of the string on the pulley, that is some pi r length, is equal to the total length of the string. Let. From here we can find out that this x1 may vary, this x1 length may vary, this x2 length may vary, but this pi r length will remain constant. So again one more further step we can write as x1 plus x2 equal to some L minus pi r, which again will be a constant value. Now this is what we have started to identify the generalized condition for pulley block system. One mathematical expression need to be evaluated, differentiating with respect to time. So if we are differentiating this equation, I assume this equation as A, then this becomes dx1 upon dt plus dx2 upon dt equal to d upon dt of constant. As we know that if we are differentiating the displacement, we get velocity. So this will be velocity of 1 plus velocity of 2 equal to differentiation of constant is 0. It means this value becomes 0. And the condition again, if we differentiate, this is one of the relation I should put in the box, and I will be again bifurcating the facts. If again I am differentiating, the relation will be some a1 plus a2 equal to 0. So these two conditions, as I have already mentioned, that velocity and acceleration all are having the same constraint relations. Now, if you will go with the focus, I will going ahead with this only. What is V1? Actually, this V1 is the corresponding velocity of the block when the displacement x1 has been measured from pulley, because this distance is from pulley, this x1 is from pulley, this x2 is from pulley, this x2 is from pulley. So we can say that the person who is going to identify the velocity or the observer is sitting on the pulley. So this velocity becomes velocity of block 1 with respect to pulley, velocity of block 1 with respect to pulley, plus similarly for V2 also, this length is measured from this pulley, so this is velocity of 2 with respect to pulley equal to 0. Now as we know that the relative motion 1 with respect to 2 we can get as V1 minus Vp, that is velocity of 1 with respect to ground minus velocity of pulley with respect to ground, plus again explaining this one as velocity of 2 with respect to ground minus velocity of pulley with respect to ground. The simple calculation becomes V1 plus V2 equal to 2 Vp, and this implies Vp equal to V1 plus V2 by 2. This is the important term to be remembered. Similar pattern also we can write it as acceleration of pulley is equal to acceleration of block A1 plus acceleration of block A2 by 2. We need to remember this, and the further application of the Pully constraint is depending on this only. Now suppose in the previous session which I have mentioned here, you can look here that we have assumed the pulley is fixed. Pulley is fixed, it means velocity of pulley is 0. Velocity of pulley is 0. Now suppose the same explanation can also be get out from here, because as I have already mentioned, this is a generalized concept we are moving. Suppose velocity of pulley is 0. Velocity of pulley is 0, it means this term is 0. And again, if this term is 0, it means V1 plus V2 equal to 0. This implies V1 equal to minus V2. What is important? That the value of magnitude of V1 and V2 is same but moving in opposite direction. It means if this block is moving in downward direction, this will be moving in upward direction. So again, same result is coming here also. So this is the generalized condition where we will be implementing some concepts. Some few points to be remembered in this is, we are moving to another session, that I am again writing this on page, that velocity of pulley equal to V1 plus V2 by 2. This is very important to identify. One important point that it has to be remembered is whenever you are putting the values of V1 and V2 or Vp, because out of the 3 parameters, 2 parameters will be given and the third one has to be identified. So you do not care about the third which has to be identified, but those parameters which has been given must be having some conclusion. That is what is that you need to check the sign of the points, the parameters. That suppose if you are taking block is moving in upward direction or the block is moving in downward direction, you need to check the sign. I am explaining with the example, it will be better to clear. Suppose this is a pulley. I should cut this. This is a pulley. This is a block. I should say this M1. And this one block is M2. This is moving with 2 meters per second, and this is moving with 4 meters per second. Now the question is, what will be the velocity of the pulley? Very simple to identify. The first thing, you identified that this is a 2 block pulley system. 2 block pulley system means I have one formula. That is Vp equal to V1 plus V2 by 2. We need to find this parameter, so we need not care about the sign and all these things for this one, but we need to think about this. Since this block is moving upward direction and this block is moving downward direction, so one direction has to be taken positive and the corresponding opposite direction has to be taken negative. This is all about us, how we believe. If we are taking upward direction as positive, then downward direction will be negative. If I am taking downward as positive, then upward will be negative. So in this question, I am taking this upward movement as positive. So if I am taking upward as positive, it means this 2 will be plus and this V2 will be minus, because this is in downward. So this is minus 4 by 2 equal to minus 2 by 2 equal to minus 1 meter per second. Now what is this minus 1 is showing? This minus 1 is showing that the pulley is moving in downward direction. So this minus sign, as we have pre-assumed that minus is in downward direction, that's why this minus 1 indicates that the velocity of pulley is 1 meter per second in downward direction. I am taking one more example. So another example is, this is pulley and this is one block M1, this is another block M2, and suppose this pulley is having velocity as 5 meter per second and this M1 is moving in upward direction with velocity 3 meter per second. I assume it as B1. This is velocity pulley and the velocity of M2 has to be found. What will be the value of M2? So again what we are observing here, this is again a pulley block system. So while finding the answer of this question is very simple, that velocity of pulley is equal to velocity of the block M1 plus velocity of the another block M2 by 2. Again I am mentioning that those parameters which has been given need to be taken with sign. Sign means if you are taking upward direction as positive, then downward direction should be negative, or if you are taking downward direction as positive, then you must say that upward direction is negative. But those parameters, the parameter which is unknown, need not put any sign. Now we need to find here the value of V2. Now I am taking this as a parameter upward direction as positive, and if I am taking upward direction as positive, it means Vp is moving in upward direction, so this is plus 5 is equal to V1 is moving in upward direction, so this is plus 3 plus V2 by 2, solving V2 plus 3 equal to 10. This is V2 equal to 7 meter per second, that is coming with plus sign. This plus sign indicates that this block is also moving in upward direction. I hope this concept would be clear to identify the various issues. Now again one session I will be clearing. One more example I should say, that suppose this is pulley, this is block. Now you can easily answer this question. This is again a pulley and this is a block, this is M1, this is M2, another block is attached as M3. Now we can easily identify that this pulley and this pulley is fixed, but this pulley is movable. It can move in upward or downward direction. So easily identify that this acceleration velocity component will be same because this pulley is fixed. First time we need to recognize the pulley. This pulley is fixed, so this side and this side will have the same velocity. But this side and this side will have different velocities. Why? Because the two sides are attached with a movable pulley. Again, if I am talking about this pulley side, we are taking about this pulley section. This side and this side is attached with the fixed pulley, so this component and this component will be same. So suppose if I am taking the velocity as V1, V2, sorry, this one as V1 and this one as V3. So what will happen here, that the velocity of this section will be equal to this. It means this will be moving in downward direction. Suppose I am taking it in downward direction. This is V2, this is V3, V2. So V2 and this one will be upward direction V1. So V1 will not be equal to V2. I hope you understand the fact that if the pulley is fixed, both the sides velocity components will be same. So V1 is here, it means V1 will be here. V2 is here, it means V2 will be here. But since this pulley is movable, so both the sides, the components will be different. This implies V1 will not be equal to V2. This is multiple pulley system can be attached. So easily you can identify the two block system, how the pulley is moving or pulley is not moving. This is all about the constraint pulley relation, and further step I will be discussing the important questions. Remember that this video will have the further session also, where I will be discussing the advanced session, because there are some tricks. 4 to 5 types of tricks are there to identify the relation. This is the basic method. This velocity of pulley equal to the velocity of the one block plus the velocity of second block by 2 is a basic fundamental method. Wherever you move, this method is universal. But in parallel, while you are finding the constraint relation, there can be multiple number of pulley block system, more than 10, 15, 20, 40. So those fundamental relations, how can we find? For those relations, this is the process. Of course, this is the basic process, we can move ahead. But every time if you will be putting out this method, it will be time taking for us. So in advanced level, I will be discussing how to identify the relation of all these two within 5 seconds or 10 seconds. I assure I will be dealing with the 3 to 4 tricks that is used to handle out the constraint relation, and that hardly takes 5 seconds or 10 seconds to identify the relation. So this is all about the constraint. In advanced session I will be discussing the respective details.